Hi everyone, in this video I want to talk about writing recursive equations of sequences. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question: which sports, if any, do you see yourself playing in the next several decades? Alright, so recursive formula, this falls under sequences today. In Algebra 2, you have arithmetic and geometric sequences. Now, I have videos on one on each of those types of sequences. These do come up on the test every so often. You can expect maybe one problem related to sequences per test. They ask a variety of different questions. One of them is related to an explicit formula, and another is related to a recursive formula. So the other two videos I have talk about the explicit formula, but there are two standards related to the recursive definition. So I think we should talk about both of them and the similarities and differences. Okay, so before we get into recursive, let's talk about the explicit form. Okay, so explicit form of arithmetic versus geometric. Okay, the explicit form of an arithmetic sequence goes like this. A sub n, meaning like whatever term you are looking for. Maybe the first term would be a sub 1. The 10th term would be a sub 10. Equals the a sub 1 plus d times n minus 1. Okay, so a sub 1 is first term. The d number is the difference, the common difference, which is the same thing as a jump. So like, which of these two is arithmetic and which is geometric? Well, we can tell based on the patterns of the numbers. Right away, right here, I can tell we are, the jump that we're making is we're multiplying by -5. Some people refer to that as the rule. So that is not arithmetic, that is geometric. And this one I can tell because we are adding 9 to one to the next. That is an arithmetic sequence. So we are going to use this first equation here. The first term is -34. Remember, a sub n stays a sub n because we need that nth term, whatever term you're looking for. But then I'm going to add in the jump number, which is 9, and then we'd multiply by n minus 1. So occasionally the test will ask you for, say, like the 50th term. You would plug in 50 for n, meaning you get -34 plus 9 times 50 minus 1. So 9 times 49, and then subtract 34. That would tell you the answer. But remember, we're still working on recursive. So explicit to recursive, I have also seen that that conversion back and forth. So let's keep going with this explicit direction. A sub n equals, and then a sub 1 times r to the n minus 1. That is how you'd write an equation for geometric. So this is the common ratio. That's like the jump when it's multiplying from one to the next. Arithmetic, like I said in my other two videos, you add from going from one to the next. This one you multiply it by a number going one to the next. A sub 1 is always the first. Okay, so that means that our explicit form for this next one is a sub n equals what? -5 the first term is -1, and then multiply by the r to the n minus 1. So that's how you would generate any term in the sequence. You could plug in 1, 2, 3, 4, all the way up to infinity to generate a number. But I have not answered the question yet. So it's asking for recursive. Okay. I think explicit is easier, which is why I started that way. But the recursive definition for, I'll put that over here. Recursive for arithmetic goes like this. So you actually write out a piecewise function, which can sometimes scare people, but it's like you put the first term is, so you would write out the first term for the first one, and then you would have like the if statement would be if n is equal to 1. Okay. Then the next case would be that you would take the a sub n minus 1 and then add it to the common difference. So that is when n is greater than 1. Okay. These two cases are always going to be like that. If n is 1 and n is greater than 1. This number will always be the first term. And then this you can think of like it's always the previous term from whatever you generated in the past. So like if you're looking for the fifth term, you would need to know the fourth term in order to figure out the fifth. So that is pretty darn similar to the geometric way of writing a recursive formula, and that is it's a sub 1 again, and that is if n equals 1. But then this next one is a sub n minus 1 times the r if the n is greater than 1. So how do we actually use those in this situation? For arithmetic, our recursive definition would be, we always want the first number, so that is -34, and that's if n equals 1. That's like every time the n is 1, you just list the first number. And then next is the a sub n minus 1, which we don't know because, we're just writing an equation for this. But that's going to be plus the 9 if the n is greater than 1. And that's all we can do. That's where we stop right there. So that's recursive for the first one. The recursive formula for the second would be you put the -1 because that's the first term. You say if n equals 1. This will be if n is greater than 1. Then the a sub n minus 1, we have to multiply whatever that is times the r number, so times the -5. Okay, so if you look at those and kind of think of the formulas, you would be able to try some practice problems. I have some that are very, very similar to the first that you saw. You'll have to decide which one's arithmetic, which one's geometric. I did give you one of each. And why don't you pause, practice, and I'll reveal the answers. Okay, answers are here. The common difference was -200 on that last one, and then the jump for the next was 2. So I hope this video helped you in some way. Maybe after this practice, you'll see a problem just like these and get it right. So there's a Winston Churchill quote that I'd like to leave you with, and that is, "To improve is to change. To be perfect is to change often." And to be clear, I don't think we should be trying to achieve perfection here, but I think this is a nice reminder that we need to work hard towards something if we want some good change. And and that is changing ourselves. So have a good day, and feel free to keep up with my videos by subscribing. If you have an answer to the fun question, feel free to comment. Thanks for watching.